This video is going to talk to you about inequalities and all the things you should remember and know about them from your experiences in the past and show you what you need to know for 8th grade. All right, the first thing we want to do is define the word inequality. An inequality is a mathematical sentence that contains symbols of less than, greater than, less than or equal to, greater or equal to, or does not equal. Basically, it's every symbol other than the equal sign. All right, that's what unequal means, is not equal. All right, so when we're translating, just like we translate for equations and expressions, there are certain words that mean certain symbols. So the 4 major symbols are your less than, greater than, less than equal to, and greater equal to. And they each have some words that would go under them that when you see them, you would know to put the symbol that you're looking at. All right, so we're going to start with the less than symbol. There's only a couple of words that we would see the most here. Obviously, if you see this symbol, it's going to say in words less than. Now be careful because less than also shows up in our equation words as a subtraction problem. All right, so you've got to kind of read through the problem completely and see whether it's talking about an inequality or not. Okay, along with the phrase less than, fewer than is also going to mean to put the less than sign. Right, if you have fewer than $5 in your pocket, you don't have $5, but you have less than that $5. All right, on the flip side of things, you have the greater than symbol. So obviously the phrase greater than is going to show up. Okay, and instead of fewer than, this is where more than is going to come in. If I say you have more than $5, then that means you have 6, 7, 8, etc., but you don't have 5. You just have more than 5. All right, and then another phrase that tends to pop in here specifically with speed is exceeds. Right, if you were going to exceed the speed limit, you are going over the speed limit, so that would be greater than. All right, so for the next two, you have less than or equal to and greater than or equal to. Right, and there's some words there that we want to make sure you understand what you're looking at. Right, obviously the words that make the symbol are going to be there. So you're going to see the phrase less than or equal to. It's not a choice, it's the whole phrase. It's all going to show up there. Then you're going to see the phrase no more than. If I say you have no more than $5, then that means you do have $5, but you have less than $5. You just can't go over the 5. Okay, and the other phrase that you're going to see quite a bit of is at most. If you have at most $5, then you have $5, but you have less than $5. You don't have anything more than that. The most you can have is that 5. All right, so then the flip side is the greater or equal to sign. So just like last time, they will actually write out the whole phrase, greater than or equal to. So you'll see all of that there. Again, it's not a choice, it's a whole statement. Okay? Then you'll see the phrase no less than. So if you have no less than $5 in your pocket, then that means you have $5 or more sitting in your pocket. Right? And the phrase at least. If you have at least $5, that means you have $5 or more in your pocket. All right, so those are key phrases that you're going to see in this classroom and the symbols that go along with them. You will have to learn them on your own. You will not get to reference this chart. Right? So you kind of need to stop and think about what you're looking at as you're doing the problems. So we're going to practice with these next 4 problems. Okay, and then you can go through and see if you follow through. When you're writing an inequality, you must have 3 things. You must have a variable, a symbol, and a number in that order, right? And then your completed answer, right? So a package must weigh less than 10 pounds. Well, we don't know what size package it is. That's where our X is. We know we have to have the number 10, and then we've got to figure out what symbol goes in the middle. Well, it says the package must weigh less than 10 pounds. It can't be equal to 10, but it can be smaller than 10. So that's where the less than symbol comes in. So a letter, a symbol, and a number, right? I'm going to let you do numbers 2, 3, and 4 on your own. So when you come to class next time in this video, whatever problems I don't do with you are yours to show me as your homework points. Okay? So keep that in mind as I'm going through. So I am going to skip through some things. I'm doing a couple in each section to make sure you have some examples to follow off of. For part 2, you are to determine if each is true or false for the value given. So they're going to give you the value after the semicolon. So this one tells you that n equals 18. You're going to plug it in, and you're going to see if that makes a true statement or a false statement. So if I put 18 in place of the n, I have 18 minus 6 is less than 15. Well, now I need to do 18 minus 6. 18 minus 6 is 12. Then you ask yourself, is 12 less than 15? Right? That is a true statement. So then your answer to number 5 is true. Right? So when you do 6 and 7, plug in the number, see what happens, and then your final answer should be the word true or false. Right? For part 3, we have to go over how to graph inequalities. Right? And all inequalities are graphed on a number line, and the variable must be on the left for your graph to happen correctly. Right? So we're going to go over some symbols first, and then I'll show you how to graph 8 and 9 down below. Right? For the symbols, there are 2 of them. Right? Actually, the dots, there are 2 of them. But for the symbols, you have the less than and greater than symbols. They make an open dot on your number line. And that open dot means that it does not include the number. It just starts there, but it doesn't include the number. All right, then the other 2 symbols, the less than equal to and greater than equal to, notice it's the ones that have the equal to bar. Their dot is closed or shaded in. So it's open dot and closed dot. The meaning of the closed dot is that it does include that number. Okay, so those are the differences as we're graphing them. So I am going to do 8 and 9 to show you what the difference is between these 2 because they are different in terms of the way they're written, but their work is still the same. When you draw a number line, I require that you have 3 numbers on it so I can see that you count. You can have more than that, but you can't have fewer than that. Okay, so we want to graph x is greater than 2. So you put 2 in the middle, and the easiest way to get the other 2 numbers is to do one below and one above it. So below 2 is a 1, above 2 is a 3. I have a completed number line. Now you ask yourself, do I need an open dot or a closed dot? Because it's the greater than symbol right here, that means that you're going to have an open dot. So directly on the number line, not above it, not below it, but right on the number line, you're going to put an open circle on the 2. And you have to shade either left or right. Well, if x is all the numbers bigger than 2, all the numbers bigger than 2 are to the right of 2. So you must show that you're shading. You can use a highlighter, you can use colored pencil, you can darken it in, but it's got to be evident that you shaded one side versus the other. Okay, I shouldn't have to be able to question whether you did or didn't. All right, now there's a little trick to this. When you're graphing, if your variable is on the left, like number 8 is, then the direction that your symbol is pointing, notice that my greater than symbol is pointing to the right. Well, if you look at your graph, I shaded to the right. But this trick only works if your variable is on the left. So taking a look at number 9, in order to do this and do it right, I want you to reverse it so that the variable is on the left. That means the x goes on the left, the 5 goes on the right. Well, when you do that, you got to change the sign. Notice how the original sign is pointing to the x. When you flip it around, it still has to be pointing to the x. You can't change the direction that it's going. Now that the variable's on the left, when you go to do your number line, you can use that little shortcut I just told you about. Put 5 in the middle. 1 below 5 is 4, 1 above 5 is 6. Now you need to figure out what kind of dot you need. Because it's less than or equal to, that piece of the equal bar is there, on the number 5 we're going to put a closed dot. Right? And because we moved our variable to the left, you can tell that the arrow or the symbol is pointing to the left. So x is all the numbers smaller or equal to 5. Well, that would be everything to the left of 5. Okay, so if you're going to flip it around, just make sure it's pointing to the same spot it was pointing to in the original problem. But if you're going to use the little shortcut trick, then you have to have the variable on the left or it will not work. All right, for 10 through 13, you are taking and writing the inequalities, right, that come off of the graph. Right, and there are some unique ones in there. So I am going to do numbers 10 and 13 with you and let you try 11 and 12 on your own. For number 10, remember you have to have a letter, a symbol, and a number. So I'm going to use the letter X because that's my generic letter that I like to use. The number is where the dot is. So the dot is at -4. Now we need to figure out, because it's an open dot and because it's shaded left, what symbol to put in the middle. All right, so here are your choices. With an open dot, you have the choice of the less than or the greater than sign. And if you notice the shading is all the numbers less than -4. So right here, it's going to be x is less than -4. That's the inequality that makes that picture happen. Now, when you go to number 13, you'll notice there's no shading. And that's because this is not an inequality, right? All this graph is saying for number 13 is that the answer can be 16. Right? So we say x equals 16. So you won't see this happening, right? Because it's not an inequality. That's an equations graph, right? That's what the dot looks like when you graph an equation answer, right? But that's technically not an inequality. So I wanted to make sure you see the difference between those two. All right, then the last part of your notes is solving. And we solve inequalities exactly like a normal equation, except for one thing, and that's what these big capital letters are about right here. Okay, when you multiply or divide by a negative number, so it's only multiplication and division that works, by a negative coefficient, that means that number has to be attached to the letter, you have to flip the inequality sign the other direction. Otherwise, the answer does not come out to be a true statement. All right, so we're going to take and do a few of these together, and then again, the rest of them that I don't do with you in this video, you're going to complete as part of your homework. All right, so let's start with number 1. All right, think of it as a normal one-step equation. These are only one-step and two-step. You don't need to go any higher in this class. All right, so if we want to get n by itself, we have to get rid of minus 4. Well, the way we get rid of minus 4 always is to add 4 to the other side. Okay, so now it crosses off. Your format is exactly the same as an equation. Nothing changes other than the symbol part. So now you have n, right, is greater or equal to, and 6 plus 4 is 10. Okay, now make sure you're reading the directions. If it says solve and graph, you would then have to graph your answer, right? But these are just focusing on the solving part. All right, so as long as you get to this point, then we're good for right now. All right, but there will be some activities and things we do in class where you have to solve it and then turn around and graph it. All right, so the next one I want to go over is number 4, because that is a translating problem. Okay, and this is where you have to be careful, because it says 5 less than a number is at least negative 2. All right, well, here's less than, but that's not an inequality less than. That's a subtraction less than. This phrase right here that says at least, that's going to give you your inequality symbol. All right, so be careful and see if you can pick out these things before you do too much in the wrong way. All right, so if we're going to write this first, we need 5 less than a number. So that means x has to be in front, the minus 5 has to be in the back. Remember, less than means flip the order around. And at least, right, means that we can equal the negative 2. Okay, and then it's got to be that number or more. Okay, because at least means that's the smallest it can be, but it's got to go higher. So that's where greater or equal to comes in. Okay, so now that we've got the setup of the inequality, now we want to solve it. To get x by itself, we're going to add 5 to both sides. Okay, we are not multiplying or dividing by a negative, so there's no flipping here. Okay, so adding and subtracting does not flip the sign. Right, so your final answer is going to be x is greater or equal to positive 3. Okay, so you have to translate it right and then turn around and solve it right. All right, so let's take a look at some of the other ones below here. Some of these are one step and an occasional two step is in here. All right, so let's go ahead and take on number 6. Right, negative 14 times n is greater than negative 14. So if these two are attached by multiplication, to get rid of the negative 14, we have to divide by negative 14 on both sides. Here's an example of where you have to flip. Because I'm dividing by that negative 14, okay, then on the other side, my symbol has to flip around. Okay, so n is not greater than anymore. Now it's less than. Negative 14 divided by negative 14 is a positive 1. Okay, so that's an example of when you need to flip. Okay, it doesn't matter if the number on the right is negative. It's the coefficient attached to the letter. If that is negative and you multiply or divide, then you must flip the sign. All right, so let's go ahead and take a look at number 8. Right, because this is a two-step. Right, in normal two-step world, we get rid of the constant first, which is the minus 5. So I'm going to add 5 over. Now I've got p over negative 8 is less than 3. Right, to get rid of divide by negative 8, I'm going to multiply both sides by negative 8. Because I am multiplying by a negative number, I am also going to flip the sign. So this is another one that you flip. Okay, you don't always flip them, but I'm showing you the flipping ones because that's the ones you tend to mess up on. 3 times negative 8 is going to be negative 24, and because we need to flip the sign, it is not less than, it is greater than negative 24. All right, so your job is to complete all the ones in between that I didn't do in this video. Come to class, we'll talk about the answers, and we'll see what you still are struggling with and what your issues are that we may need to clear up before we continue on.